5,000 share order.
Hey everybody, good morning, good evening, wherever you are in the world. Thank you so much for tuning in to another episode of Google Cloud Live. I'm Stephanie Wong, and I don't know about you, but I am still riding the post Google Cloud Next high. We just wrapped up an action-packed 3 days in Las Vegas, and it was an absolute blast. If you were hanging out with us here on the stream last week, you know that we talked to a massive lineup of experts. Our DevRel team stopped by to talk about the new Gemini Enterprise Agent platform. NVIDIA and Base 10 dropped in to chat about Gemma 4. We had the Wiz team on the show for the very first time, and the hosts of the Acquired podcast joined to share their reactions on the announcements. We also got to pick the brains of Harrison Chase, the co-founder and CEO from LangChain, and Michele Castata, the president and head of AI at Replit. So it was a packed week. So if you missed any of it, just check out the links in the description to watch the video on demands. But we aren't done with Next just yet. While we were on the show floor, we actually filmed some bonus episodes just for you. So today we're diving into the new agent skills announcements, orchestrating autonomous agents, catching up with the Flutter team, and sharing some really great conversations with our Google developer experts. So wherever you're tuning in from, sit back, grab your coffee, and enjoy the show.
Hello, and if you saw the dev keynote from Next, you already know what I'm going to talk about. But if you didn't, or you want a little bit more detail, this is the session for you. We are, in the dev keynote, we showcased agent built out with multiple agents working together, including tools, including different aspects of how to build an enterprise-ready, production-ready agent. And a part of it, we started off somewhere, and that we started with something called the planner agent. Now, we have a marathon, and you know, plan, it's a fairly complex process. And this is something we did with basically human intelligence, with time and a lot of people working together, designing an agent, designing the plan, designing the race and everything. And we took the task of, okay, can we take that process and make it so that a bunch of agents working together can do the same thing, if possible, even better. And started off with building an agent. And when you go to build agent in 2026, you have a lot of options. And we believe that ADK, Agent Development Kit, is the best way to do this. And ADK, if you're familiar, if you're not as well, ADK is an open source project that we started at Google, but it's open source, so anybody can access it. And any language you prefer, like usually, again, the main library was built in Python to start with, but after that, we also have libraries for ADK in Go, TypeScript, and Java. So whatever language you prefer, we have something for you. So that's our base. We build the agent on that. But agent just on the language and the model, and then for the models, we have many choices. We obviously believe Gemini models that we have available, Gemini 3, 3.1, the Flash, the Pro, all of that can give you the compute power needed for the agent's brain to do things, but you can choose any model that you want, right? Like you can bring in Claude models, GPT models, your open models that you're running on GKE yourself or like any other place. So you can bring the agents with the model. Now you have the agent, now you have the agent's brain, but that is so 2025. You have the agent and the model, but that is not all you need to have the agent be intelligent and do things into the world on its own. The next two things you would need for the agent, that would be the skills and the tools. Now, tools are just functions, right? That tool function can be just a compute that is happening as the model needs to compute something, but that tool call can also be affecting some other service. It could be an MCP server the agent is talking to. It could be some database the agent is accessing. And then you have skills. So skills are a fairly new concept. The way skills work, it's you have basically two parts to a skill. You have the YAML metadata and you have the markdown body, right? So the YAML metadata is fairly short. It just describes what this tool's name is and what is the core thing that this skill does. And when the agent like basically starts up, it will load up all the skills it has in the context. So it has all the skills and only has the information of the YAML metadata. Now it knows I have like 7 different skills, let's say, and each of the skills do X, Y, and Z. And then when I need to, when I have a task that fits one of the description, then I can go off and get the rest of the markdown body, which can be fairly long, which can have code, which can have scripts, which can have other references going off onto something else. So you can have your context be fairly short because you are just loading a short amount of description. And then once you have loaded all of that, once you need that particular skill, you can go off and download the rest of it. So all of a sudden you have this fairly clean context, but the tools you need, you get them in point. So tools, skills, together, you can have a fairly clean context. And once you have done all of that, now your agent is no longer just dealing with prompt. It is efficiently managing context and doing the task you need to do. Before we jump any further, I want to quickly show you, if you missed the demo, what we're looking at. The app we built out is the simulation application, is this beautiful simulation of Las Vegas in 3D. And this simulation application, and we're looking at the first version of it, the one I'm talking about here. We're sending in a prompt saying, plan a marathon in Las Vegas for 10,000 runners, right? And I'm going to go ahead and send this prompt off. And what we're going to see in a second, what happens, is we're going to start seeing that a tool call happens, load skill, GIS spatial engineering, then plan a marathon route, then load a skill called mapping, then we load a skill called race director, right? So again, our agent started doing the work, and as it was going through it, it found, okay, I need to have this particular skill because at this point in my prompt, it looks like the task I have at hand would be better if I had a specific skill loaded, right? So after all of that, so there is a bunch of things happened, right? Like, let's talk about each of these skill a little bit more detail. I'm going to look at the code just in a second too. GIS spatial engineering skill has access to a Python script, which is taking a GeoJSON data and calculating a viable route that would fit our marathon criteria. One of the key ones is the length, like 26.2 miles or 42.195 kilometers. Very specific. So we are doing some very specific mathematical operations on those like route coordinates to find a route that goes through Las Vegas and satisfies that criteria. After that, we have some other criteria like, okay, we don't want to have elevations in the back half of the marathon. We want to have water station placed in a certain locations. All of that is being calculated through code. We don't have our model to randomly guess or make up that information. That information has to be grounded to the real world somehow. So we're doing that by calculating GeoJSON data that way. We have another skill called mapping. So mapping skill here is actually taking advantage of Google Cloud Remote MCP for Google Maps. So Google Maps, again, all of you know, Google, we have been mapping the entire world for years now at this point. So we have a lot of information about each location, each coordinate of the world. So what is there? What kind of things are there? On top of that, the Google Cloud Remote MCP for Google Maps, we also have information about weather information. So if you're trying to plan a marathon, you probably don't want the marathon to happen in a really hot day or a really cold day or a really rainy day. So with that historical weather information, you can start now planning a little bit better. So this one just calls the Google Maps API underneath, right? Google Maps MCP server is just a way for us to access the Google Maps API without having to know all the API query. We can just use natural language to talk to the Google Maps API. So we have, number one, we have the GIS skill, which calculates using Python code, handles the calculation there. We have the mapping skill, which now talks to Google Maps MCP server. And the last one we have is race director skill. Now the race director skill here, it's kind of requirements, but these are not hard requirements. These are just, if you're planning a marathon, you would probably have this documentation that says, okay, do these kind of things. Make sure the initial starting point have 3 or 4 lanes, because in the beginning, there are lots of runners that are trying to run through the same area. If the road is too narrow, you're gonna have a choke point. Or you need to have this many water stations spaced apart this many distance. Or something like you need to have this many porta potties, right? So all these requirements that are not necessarily directly required for the race itself, but absolutely required to have a successful marathon. So all of that information is not necessarily something hard-coded, but it's codified in text. And that used to live in a Google Doc. And what we did is basically take that Google Doc and talk to Gemini about, okay, this is my Google Doc, which is useful for humans to read, but not super easy for machines to read. So can we take that doc and convert that into a skill? And again, models are really good at summarizing or converting one type of text to another type of text. So that was pretty straightforward to take the Google Doc. We use the Google Workspace MCP server. We didn't really talk about that much, but we use the Google Workspace MCP server to pass the Google Doc as a link, and we can then convert that into a skill for ourselves. So this is on the right side, where you see on the right side here, that is our simulation application calling into our planner agent. Now you might be wondering, okay, this is a nice UI and all, but how do I go about doing this all myself, right? So this is not just like we're just showing you this and you have to take our word for it. All of the codes that you see here are actually available in the GitHub repo that you can go run yourself. So that we open sourced this repo yesterday as during next week open source it. So you can just go ahead to this repo. I'm also going to put the link on the video description later that you can go find it. It's called race condition. That's the simulation application. And within the race condition simulation application, we have a few different things here. First of all, this is, again, development in 2026. We took advantage of a lot of this coding harnesses like Claude, Gemini CLI, anti-gravity. So if you're using Cursor, Claude, Gemini CLI, any of those, you'd be able to go into this repo and you'll see this. We have agents.md files for Gemini.md file, and we also have Gemini skills that you can take advantage of. We also have things like Claude skills, right? If you're using Claude, you can use that to also help deploy or contribute. And then all the agents that we're talking about, the one I'm talking about is the first one to start off, which is the planner agent. And all the code is here. You can jump in and take a look at how each of these parts work and how they work together to do the things we do. But I want to quickly show you the skills we were talking about because there is a lot of them here. So GIS spatial engineering, just open up one of the skills. And I'm going to bump up the font a little bit because it makes it easier to read. So the thing we talked about, I'm going to take a look at this text in raw format so we know exactly what the agent is. So start off. We have a name, right? We have a name called GIS Spatial Engineering, and we have a description. Description basically just says it's a GIS tool, and it generates mathematically perfect marathon routes of exactly the right length. And after that, we have a bunch of body, right? The text, it says how it works, what it does. Now, in the beginning, on the model, only this part was loaded. We only loaded this into the context, and we also loaded all the other skills that we have in the system. After that, as the model was going through our task list, when it hit a point where we said, okay, calculate the route now, it knows, okay, I have this skill that says expert GIS tool for generating routes. At that point, it will go ahead and load the rest of the skill. We'll also see in a second, as part of the skill, we have something called scripts. Inside scripts, we have this function. And again, this is just Python code. It does a lot of mathematical calculation. It is fairly long. It is fairly verbose. So again, if you have the time to or you want to understand this, I would probably just load this up on Gemini and ask, okay, explain what this code does. But generally speaking, it is doing a lot of calculation on GeoJSON data. For Las Vegas, we also have this network.json file, which is a giant JSON file, GeoJSON data. So again, GitHub was nice enough to be able to create a map out of it because it's GeoJSON. It knows how to deal with GeoJSON data. But in reality, it is just a big JSON file with coordinates, with lines and things. So if you look at the mapping view, actually quite fun to see, we basically have all the points in Las Vegas that is mapped out. And you could see, and we almost made a geofence to say, okay, when you draw the map, make sure that the map doesn't go beyond the boundary. We don't want your marathon to end up in the desert, right? That would be a terrible end to a marathon. After running for hours, you end up in the middle of nowhere. That's not fun. So we can end you in a location that is geofenced by the Las Vegas city boundary itself. All right, so you have that skill, and then we can look at the other couple skills we talked about. The next skill we'll talk about is mapping skill. So mapping skill is going to be fairly straightforward because it basically just says, okay, when you need to have any mapping capability, go ahead and use the Google Maps MCP server, which itself comes with 3 different tools underneath, which is search places, compute routes, and look up weather. right? We're not going to take advantage of the compute routes. But again, you have to remember, Google Maps, the tool, is not meant for just like calculating running routes. It calculates more like walking routes, bike routes, and car routes. We could use that to get general idea of the distance, but still it would be not as good of a calculator of a marathon route because they're very specific. We don't want any loops or crosses onto the route itself if we don't have to. So lookup weather is the one we're using. Another one we're using is search places, which is to find out information about individual points onto the map. Also find things like landmarks, because again, we don't want to have a marathon in Las Vegas where we don't see any of the famous Las Vegas attractions. So Google Maps search places would let us easily find the big places like, Bellagio, the Fountain, or the Sphere, all of these locations that we want our runners to be able to see. So that is that skill. And the final skill we have here is a race director skill, which is, again, it's like a text-based skill. We basically took a Google Doc and converted that in the race director skill that we can have give some non-deterministic criteria a little bit and tell it how to plan the race well. We have a couple of other skills here that we don't use for the first agent, but they're still here. For example, when you plan a race this big, you need to have planning for how do you deal with cost and how do you deal with economic impact of having this race disruption to the city. Okay, so that is the code. We're gonna link it at the end so you can go try it out. On top of that, on trying everything else, we also have access to a code lab that we created out of this. So if you want to just go through and build this agent out yourself, it's going to be fairly straightforward to go and clone this repo. I'm going to go to the repo myself. So all the demos we saw actually have code labs built out for them. So for dev key, we have the demo 1, and you'll see step by step how to get access to the code. This is probably an easier place to show you the race director skill. So yeah, this is just like a text-based skill. We also have another reference that is here that you can go, again, non-deterministic criteria, like for how many people, how much of a wide road do we need? For a larger road, a larger amount of people, we want a bigger road because, again, a lot of people are starting at the same time, and how many lanes we need minimum, right? Bigger is better, but at least in the minimum we need this. So traffic impact as well, all these criteria, these are harder to calculate deterministically, but we still want to give the model some information about how to think about these things. Once you have done all of that, right, you could then have the agent deployed to your favorite place. We recommend using agent runtime. You could also use Cloud Run, GKE. But when you're thinking about building agents in 2026, it's not about just, okay, what model I choose and what agent framework I use. It's more about how do I give the agent the right tools, the right skills, and the right the place to run so that it can scale to the place you need to scale to, as well as it has the right tools to be able to do the task at hand. And again, this is going to continue to evolve. We're going to learn more, and we're going to have more things. Like ADK just released its 2.0 release. It has a nice new, a graph-based feature now. So we'll be able to build much bigger and better agents in 2026 and onward. The demo we build out for next is going to be a good reference point for all of you to start building agents in 2026. We have the code lab that you can go follow this agent as well as other agents. We also have the code for the simulation application that we can go clone and try it out yourself, as well as try out ADK and Gemini together, build your agents in 2026.
What's up, nerds?
Let's go.
Well, Yvonne, we're here after the developer keynote. We presented a demo. We call it internally Demo 2.
Demo 2, yes.
Yeah.
It was such a great experience. How do you feel the day after?
I feel good. My voice is a little raw. I did not anticipate the consequences of my actions when I colored my hair this bright color. I knew it would look good on stage, but what I didn't know was that I would become instantly recognizable to everyone in the conference.
Yeah, it happened to me as well. A lot of people, they meet me on the floor and they were asking, that was a cool demo. How do you build that? Great delivery, all this kind of thing. It was pretty nice.
Yeah, maybe we should get into that. So For people who don't know, I'm a developer advocate at Google Cloud. My name is Casey West.
Hi, everyone. I'm Nguyen Nardini, same role of Casey on the AI part.
Right. And so we delivered a demo that included multi-agent architecture, real-time evaluation, A2A, and A2UI, agent registry, a lot of things. But maybe we can go through each of these things and a little bit of how we built it.
Yeah. I mean, I would say that it was a long journey, right? We started building this demo, I think, in February. The initial part was kind of figuring it out, like not only the scope of the demo, but how to combine those services in a way that, we can leverage all the capabilities that they provide. And I think for me, the most exciting part was, designing, thinking about, hey, how we can combine these agents, and for each agent, what kind of capabilities we want to enable. So I remember, we start using tools, and then we switch, and we decide to differentiate between tools and skills.
Even pulling back a little bit more than that, I know that when we were thinking about the concept of planning a marathon and introducing additional agents beyond just a planner agent, I know you and I started thinking about what are all of the, identities that have to go into planning a marathon in a big city like Las Vegas. And so, we initially had thought maybe we'll have half a dozen agents that will all work together.
Yes, exactly.
And they'll all have different jobs, right? But sometimes, that sounds like a good idea. And then we get into implementation and we realize a few things, including the unnatural constraints of a keynote presentation, which is very tight on time. The more agents you have, the more network connectivity and latency you have, can slow things down.
Yeah. No, I remember the initial prototype that we got. It was running perfectly, but it was taking so long to produce the output that we were expecting, right? So that's when we start considering, okay, we cannot have thousands of agents running in the backend. We need to squeeze them, and for sure, at some point, we figured out that it was not just about the number of agents, but it was about the single component that each agent has, and as well as how we can optimize the communication between the backend, the agentic backend that we build with the front end that yesterday we showed.
Right, and so we ended up settling on a 3-agent architecture, the simulator, the planner, the evaluator. Something that I think is kind of fascinating to dig into a little more would be the evaluation process. Why would we want to have a separate agent for the evaluator when, in our case, the evaluator was only used by the planner agent?
I think, if you remember, when we start designing the system, we were discussing this idea of the agent as a judge that will allow us, to iterate on the evaluation itself. And actually is one of the patterns that is kind of, I don't want to say that it's common out there, but is a possibility that people are exploring. So I think that's where it came in, and we start experimenting with it. And we start thinking, okay, how we can integrate this pattern in the entire agentic multi-agent system that we were building.
Right, and another big piece of it is making sure that we've got essentially a different model grading the results or the generation of one model. So in our case, if we use Gemini 3 Flash to generate a plan, how can we have confidence it's a good plan or it's an accurate plan? We use an evaluation and we do it in real time, but we also use an alternative model, in our case, Gemini 3.1 Pro.
Yeah, correct. Yeah, and this is because, we want to avoid some biases that, using the same model will inject in the system. So that was a kind of a great conversation, I remember, about the evaluation part. The other one that I really enjoyed, as I was saying before, was at some point we had to figure it out, okay, should this functionality that we want the agent use be a skill or a tool? Right. And that was a kind of a big moment, I remember. We had to reiterate and change completely. So I think that would be interesting, to discuss.
Yeah, and it can tie in a little bit, for example, to the A2UI
Yeah.
components or agent to user interface,
Yeah.
where we had multiple agents in the system that could emit A2UI as part of their generation. And so the way we built that was through the use of skills. So we have a skill that we gave to every agent that needs to do A2UI that explained how to be essentially an expert at A2UI. Using the default catalog. And if you look into A2UI, that's essentially a list of around 18 default components. So it's things like a text, a bunch of form fields, modals, things like that, images, video. And so that allowed an agent to know how to do A2UI. And then I also bundled in a tool with that skill. So a skill can be a prompt, additional prompt and instructions, and it can also bundle tools. So I bundled a tool to validate emitted or generated A2UI. And it's kind of similar to evaluation where I want to check the results because the agent emits a JSON payload that describes the UI that it wants. And of course, a UI or client, a front end, has to render that. So we want to make sure that we're giving it valid A2UI. So I also have a tool to do that validation.
And yeah, and I mean, as we are saying, like this topic of evaluation, like it's recurrent while you are building, multi-agent system. And in fact, like also here on the floor, one of the most common questions that I received was, hey, but you build such a great multi-agent system, but how do you evaluate it? Like, how do you like be sure that those results are aligned with what you expect, and in particular, they make the system stable. So, I mean, if one thing that I take home from building this keynote demo, for sure, is that evaluation is not just a one-time thing, but it's something that is recurrent while you are building the entire agent system.
In our case, with the evaluation that we built into the evaluator sub-agent that went into the planner, we also connected it to the evaluation service on Gemini Enterprise Agent Platform.
Yes.
New names, always getting used to them. And that allows us to track our results over time as well. So you can get the real-time evaluation, but you can also have ongoing data about the quality of your agent and what it produces.
Yeah, for people that don't know the services, essentially it's a managed services that provides you an API with a bunch of metrics that are pre-built, but the services is pretty open, so you can customize your metrics. So what we did with Casey, essentially we combine like a subset of custom metrics with some metrics that were pre-built, so we could speed up the process of evaluating an agent. So I think for sure evaluation is one of the key things that we had to consider while we were building. Another thing that for me was fascinating is that I mean, A2A is a great protocol, and I don't think we had many problems on connecting and using A2A in order to build a multi-agent system. But what I remember is that once we got the initial prototype of the multi-agent system, it was working, it was running, but it was taking too long. And this is kind of the moment where I personally realized, this is the difference between building a multi-agent system that kind of works with something that actually needs to perform and needs to be processed, for example, a task in a certain amount of time. And so that's when you start thinking, okay, we have the backend, but we need to find a way to optimize it. Right. And I know that you spent a considerable amount of time to optimize it in a way that was fitting with the front end.
I did. So a couple of things that are worth considering. One of them, even just starting with evaluation, but then moving on, is we started with around 7 different types of criteria we were evaluating. And we were making different calls to the Gemini model we were using for evaluation for each criteria. That's nice to keep independent context and keep things really focused. Mm-hmm. But of course, when you're trying to, when you have a speed constraint, when you have a latency constraint, you have to optimize that a little bit. So we decided to bring all the non-deterministic criteria checks into one call. And of course, using Gemini 3.1 Pro, very capable of being able to handle that, manage, and focus. So that was good. We also, the marathon plan that we generated wasn't massive. It wasn't, you know, widespread sort of needle in a haystack problem. So it was able to focus and give us good results. A couple of other things that we did, though, these are just little tweaks that aren't always on by default. So, you know, omitting streaming server-side events helps just with the perception. That was a big one. That's available, and you can do that on Agent Engine. You can do that if you deploy to Cloud Run, Agent Runtime, or if you deploy to Cloud Run. So that is really helpful also for perception. Trying to think about what else. There's one trick that's actually a little beyond our demo, and this is a little bit behind the scenes, but I built a lot of, excuse me, I built a lot of the simulation that we actually saw on stage, the sort of end-to-end picture. A2A as a protocol is something that I think we should dig into a little bit more. We mentioned the agent card, but the agent card helps expose the agent's description and name. You can expose what types of skills it has, the agent has, and also capabilities. And those capabilities can include sort of technical capabilities. So the runner agents that were in the simulation were in our demo. Excuse me, voice is a little raw, just a moment.
These are the live.
I had to talk to a lot of people.
Exactly.
Yeah, I'm working on it. But the runner agents in the simulation were, we had to do 1,000 sessions. I mean, sure.
Yeah.
I was ready to go. But
Yeah,
it's okay. I'm like, we'll fix it in post, right?
Yeah, it can be.
No, we'll keep going.
Yeah, we keep.
So in the simulation that we saw on stage, the runner agents, we had to spin up a number of them and have 1,000 different runner sessions happening at the same time. So all those little dots we saw on the screen were a single session on an ADK based agent that could speak A2A. But in order to do that, where we can instantly send 1,000 sessions a message and have the agents respond and collect data about the agents, so their velocity, their hydration levels, that sort of thing, I had to route A2A over a pub sub using memory store. So what I did was A2A is an extensible protocol. So I extended the agent for the runners to have a different callable mechanism. So it could be callable over a standard HTTP call, like most A2A agents will be, or you could call it by sending it a pub sub message. And so I just used the protocol to inform other agents and system components about how to call each type of agent. So it wasn't hard coded. So if we were calling the planner agent, we used HTTP A2A. And if we were calling the runner agent, we used PubSub.
Yeah, no, this is pretty cool. And, when you show me this kind of integration between the front end and the back end, as I told you also yesterday, it reminds me a lot of, kind of the architecture that is behind OpenClaw, but scaled it using native Google Cloud or cloud products, which I was so excited about because it allows us to kind of seeing in action like a system that is inspired by OpenClaw, but at that scale and presenting it as we did yesterday was just very, very exciting.
Yeah, I'm a big fan that when there's an open source project that is something near my type of work, whether it's a Google product or not, I want to dig into it and break it apart. And I definitely took some inspiration from models or systems like OpenClaw. They have a standard gateway for message passing that allows them to have multiple front ends that the agent can be agnostic to. And then on the other side, it's essentially like a mesh network or a mesh system for agent-to-agent communication. And so that's what we built into the simulation as well. All of the agents could actually speak to each other. There's sort of communication pathways that were built into the agents using prompting, of course, but every agent had the ability to communicate with every other agent.
No, it's pretty cool, and adopting this kind of again pattern or architecture, like we were able to optimize. Just as a disclaimer, like we had to do that because we had restricted amount of time to run and show the capability of the system. Like, of course, for people that they want to build a multi-agent system, this is not required maybe, but for sure it would be great. Like the code is public, right? So it would be great if you go there, check what we build. In that sense.
One of the things that I get asked a lot is how do you trust the output of a model? You have tools that say go and get data from your trusted data sources, and then they go through a model and the model emits that information. How do you know it wasn't hallucinated? How do you know it hadn't been modified? And of course, that was a similar problem that we had to contend with in the simulation. So on the subject of optimizations, ADK as a framework is very extensible and pluggable. ADK has a concept of plugins, and those plugins allow you to hook into the event lifecycle of an agent or of a multi-agent architecture entirely. So we also wrote a plugin that hooked into the lifecycle and emitted events, again over PubSub, during the agent's execution. Those events went to a gateway, so that's where the OpenClaw model of communication was an inspiration. And then the front-end simulation listens over a WebSocket for Protos, coming over that WebSocket for every event in the lifecycle. So that was also how we could expose the inner workings of the agents to the client. But it's also a pretty valuable technique where if you know that you're going to have a tool call that returns trusted data, you can also use event callbacks or plugins in ADK in order to even expose that data right from the tool to your clients or to other dependencies in your system that need to have guarantees that the data is exactly what you want it to be.
Yeah, I mean, playing with Protos, it can be a little bit hard, but that these are the situation where you can see the value of a technology that maybe requires a little bit of ramping up, but it provides performance.
Yeah, so imagine if you had 1,000 agent sessions all sending a message simultaneously, and you need to get that over a WebSocket to a JavaScript front end in the browser. That's what we did. So how can we optimize that? Well, we're going to use Protos, and we're going to really tighten it down.
It makes a lot of sense. Before to wrap up, like one other thing that I want briefly touch is for sure related to the governance, right? So in our case, like at the end of the day, we had 3 agents, right? But in the case of building a very large multi-agent system, like at some point we were discussing about, hey, how do you govern this system? How people that they don't know anything about the system that you build as a developer, let's assume inside the company, how these people can have a quick picture of the system itself. And so that's when we decided to introduce the agent registry. So I think it's a valuable component of our system.
Yeah, and along with the registry, other demos talked about Agent Gateway, and that's a way to make sure that you have tight controls over data access, service access, and agent access.
Yeah,
so that's good.
And something that maybe we didn't touch during the demo because all of them, they were mainly deployed on the agent runtime, but the agent registry really provides like a 360 overview of the agents that you deployed on cloud. Right. So it's compatible with other services.
Well, if people want to get their hands dirty with this, if they want to get into it, we've written a code lab.
Yes,
Admit that Yvonne did most of the heavy lifting on that code lab. So where can they find it? Look in the camera and let them know.
Yeah, exactly. So essentially, we published the collab on our collab platform. Yesterday, we shared the QR code. I think we will share the link in this video. You can find it in the comment. So, but yeah, I hope you will have time to experiment with it and provide us feedback if you really enjoyed it.
Sounds great. Thanks, everybody.
Thank you, everybody.
Hello and welcome to day 3 of Google Cloud Next. My name is Craig Labenz. I'm on the Flutter Developer Relations team, and I'm here to walk you through my 5 favorite things from Cloud Next. Of course, I'm joined by Khanh, my trusty teammate.
Hi, Craig.
Hi, how's it going? So, Flutter had a great presence at Google Cloud Next this year, and that included some pretty cool demos. Now, I know
It did.
Yeah, so you were making the rounds and spent a lot of time at those demos. So why don't you tell us about some of your favorite parts?
Yeah. I'm super excited seeing all the generative UI demos. I think it shows some really exciting use cases. We'll have videos for that on the channel. But also, there's also full stack Dart, right? We all love full stack Dart, and Cloud Functions with Dart support is super exciting to see that come to server-side development, being able to share like code and logic between your front end and your back end. Absolutely love it.
Game changer.
But to go back to generative UI, you know a little bit about generative latte, which is one of the generative UI demos that we had here at Cloud Next this year. Tell us about it.
Yeah, so Gen Latte was a pretty popular demo on the Cloud Next stage floor, and we had a Flutter and Firebase app that allowed users to kind of negotiate with Gemini and Nano Banana to settle on an image that represented their happy place. And then we had world-class baristas making actual lattes and printing those images on the actual coffees. And there was just a lot of delight in that booth as people were coming through. There was a little bit of a wait, but the payoff was totally delivering. I mean, so many smiles. The coffee was world-class at the end, so how can you complain?
Love it. Honestly, I thought the coffee was really good. Personally, I don't usually drink coffee, but I was a fan, and the cute art on top really just topped it off for me.
Yeah, and when Flutter's behind the coffee, we all make exceptions. Okay, so we also had a lot of great talks that were Flutter-based, and again, I was at that Gen Latte demo booth basically the whole time, but you thankfully were able to attend the talks.
Yep.
What were some of the highlights?
Yeah, honestly, I think my favorites, there's so many good talks, but I think my top 2 favorites was the Talabat and Flutter talk and Toyota and Flutter talk. I always love chatting with developers who use, our stuff on a daily basis to build better products for their users. And in this case, Toyota and Talabat came out, worked with Abdallah, our rockstar PM on our team, and they delivered great talks talking about how they use Flutter at scale. And that's just absolutely fantastic. Like, it was awesome.
Yeah, and speaking of talks, number 3 on our list of 5, Emma Tversky, once of the Angular team, now on the Flutter team, was able to name drop both products repeatedly in the big developer keynote. And she outlined a pretty cool, many agent, many layered, really complicated demo project that they cooked up to plan an entire marathon around the city of Las Vegas. So any thoughts you had about that?
I'm just glad that I didn't have to run in that marathon. That's the primary thing. But the developer keynote was super exciting because I've been following Chatai Ulusoy's Finnish language learning app on Twitter. And so it was super exciting to see that it got a shout out on the main stage, on the big screen. So that was super awesome.
Yeah, absolutely. So the next thing that really felt salient to both of us was just talking to so many excited Flutter developers. Obviously, a lot of Flutter GDEs here. Any specific chats, any specific folks that you were able to catch up with that jumped out or stand out to you?
Yeah, for sure. At the Flutter developer meetup yesterday, it was super exciting to see familiar faces, but also new faces as well. And it's always exciting to get to chat with folks. And folks are always like bringing new apps that they're working on, new projects that they're working on. I feel like I'm harping back to generative UI, but I got to see a couple of instances of Gen UI being used in production as well. So that's a super exciting thing for, we build demo apps, all day in, day out. But seeing it in production has been a super exciting thing there.
Yeah, they're the folks who really take it all the way to the finish line. And then the 5th and final highlight for us of Google Cloud Next 26 was actually introducing Flutter to so many people, kind of, for me specifically, coming through that Gen Latte station, talking about the cross-platform capabilities. A lot of developers were maybe cloud-centric and learning about that capability that Flutter offers for the front ends, because of course all cloud products eventually need some kind of front end. So that was always really fun for me, just tons of excitement when people see, oh, this this is one code base running on all these devices, these TVs, these phones, these tablets, these computers. Oh, interesting.
Yeah, no, that has been super cool, especially like at Gen Latte, because we have a variety of devices sitting out for folks to order their coffee. They're like, oh, so which device should I sit down at to be able to order my coffee? And I'll be like, you can pick any one of them. You get the same app no matter where you sit down. But they're like, but it looks different. It's like, that's the power of Flutter. Like, you make it responsive and it adapts to whatever platform that you're on. So that's been a super, like, it's the magic before the magic happens, I think, because folks are like, wow, like there's art on my latte, but then before that, they're like, oh wow, like it's running on multiple platforms, which is crazy because it's so normal for us as, you know, Flutter engineers, see it all day, but there's some folks who haven't heard about it yet, so that's been super fun.
Yeah, absolutely. There was so much excitement and whimsy once people got their coffee, but there was even a ton of it as people were just stepping away from the app and kind of looking back at us and being like, wow, that was so cool. So that was really fun. Now, Khanh, what should folks do if they missed any of the great content at Cloud Next and want to catch up?
Yeah, so if you missed out on any of the content, well, we will have a ton of content coming out. We have videos coming out, we've got blog posts coming out. So if you want to check out, you can find more information about anything that we talked about here today, check out the links in the video description. Yeah.
All right. Well, that's going to do it for us. We're wrapping Cloud Next 26. We'll, of course, see you online at all the socials. And, of course, next year again at Cloud Next 27.
See ya.
Hi friends, I'm Lucia Subatin. I'm a developer advocate and I'm here from Google Cloud Next.
And my name's Jack Wotherspoon. I'm a developer advocate for dev tools for Google Cloud. And I'm joined with Lucia. And you might have seen us yesterday in the developer keynote. We're here to kind of recap some of the magic that we showed in our session. So Lucia, why don't you give us a little bit of an intro?
Absolutely. So yesterday, if you want to watch the keynote, of course, you can replay it. We took demo 3, that is how we add memory to our agents. And this is very important because the more context an agent has, the more accurate it's going to be. We added different types of context. We added context through memory bank and sessions, which Jack is going to talk about. And we also added context through databases and RAG. So Jack, why don't you tell us more about sessions?
Yes, so Gemini Enterprise Agent Platform has agent sessions and agent memory bank. We showed both. They're very, very easy to set up and configure, less than 20 lines of code. And sessions automatically saves all of your ADK sessions to the cloud. So if you want to restart a session later on or save things to state, so for in our example, in the marathon planner, we actually saved all of the different landmarks that the current marathon route went by into our state. That way, if anything happened, if we ended the session, we can just pick up where we left off, resume that session, and everything is saved into the cloud in Gemini Enterprise Agent Platform. So that was sessions, and then we also covered memory bank, which is probably my favorite of the two. Sessions is awesome, and it really helps, but memory bank really takes your agent to the next level and levels it up. So memory bank is kind of similar to sessions. It's saving memories in the cloud. But what it does is every time you have a turn with the agent, so when you send a request and you get a response back, memory bank actually will automatically save that turn into memory if it finds something that it thinks or deems useful. So it could be in our talk, we talked about not having camels in the races, as that's one of the rules for the city of Las Vegas. So it would actually, if that happened in one plan, it would get saved to memory, and then in future plans, it would actually be able to pull that back. And memory bank really offloads all of that work. You're not saving things in local files. Again, it's all being saved in the cloud on Gemini Enterprise Agent Platform so that it automatically does all the work for you, which is pretty cool.
Absolutely, yes. And you said it yourself, it's 20 lines of code, easy peasy. And the other part that we covered yesterday was adding RAG, or Retrieval Augmented Generation. We used AlloyDB in this case. And I think most people who are watching this already know what RAG is, but it helps retrieving the right facts at the right time. One of the cool things that we showed yesterday is auto embeddings in AlloyDB. A lot of our databases have the auto embedding capability, and this is super useful because it takes out the load for data engineers to generate embeddings every time a new record is inserted. So basically, you can continue inserting records into the database, and the auto embedding will happen. You will have the embedding right away available for your RAG and for your agents to consume. The other thing that I'm actually very excited about is the data agent kit that was also launched this week. And this data agent kit is an extension that works on VS Code, OSS Code, the Cloud Shell, and it lets you interact with most of our databases directly from VS Code. So I'm super excited about that in particular. I think you've been playing with it a little bit. And one of the things that you can try as well, if you go into our code labs, because we did build a code lab about our demo yesterday in the keynote, is the part of the chunking of all of these rules that we had. As Jack was saying, the city of Las Vegas doesn't allow you to have a camel on public roads. So we got that from a bunch of different PDFs and doc files that we fed into our database. And that process, as most people know, is a cumbersome process if you're not doing it the right way. So you need to chunk everything in a way that you manage the context and you keep those documents in a way that they become somehow structured so that you get the embeddings for the RAG and the agents to consume in a nice way.
Yeah, super nice. And I think one thing we didn't talk about, like you said, code labs. We've got code labs for everything we showed in the developer keynote. We also have a developer platform that you can go to actually test the simulation, run it yourself. All the code is there that you saw in the developer keynote, which is something that we are taking to the next level this year. I believe we have over 75 different code labs that you can run throughout things you've seen on the show floor, the keynotes, which is really awesome. So like, this is not something that we are hiding. It is something that you can go and actually experiment with yourself today, which is really, really cool.
And it also shows that it's real, right? Like, we put in the work, we actually made this work. There is a repository on our Google Cloud Platform Git repo. It's called race/condition. And you can plan your own marathon. You can deploy this yourself. There's a one-click deployment, so it should be very easy. There's some credits there that you can use to run this for a little bit and see how it actually works. All of this is agentic. Every call that we have for planning the marathon and everything that we showed is calling agents at scale, and it's securing them as well. So you can see this in your own projects if you want.
Yeah, and one thing we didn't actually cover too is agent skills. We had an agent skill in our part of the demo in the developer keynote, and we actually also now have another repo. We're talking a lot about code and GitHub repos, but another repo on the Google Cloud repository for skills for Google Cloud. And I believe we just launched 13 brand new skills that we have curated for different Google Cloud products that you can now install and help with your development on Google Cloud.
Absolutely, and you can extend those. I think they're also very useful to understand what a good skill looks like. Personally, I extended it yesterday for our demo, for demo 3, because we needed to have like a specific treatment of embeddings, and it was a really good template to build off of.
Yeah, and I think just to kind of recap, so what we've covered is how you can improve your agent with session state, so keeping things stateful, being able to resume a session. We added memory, so memory bank, being able to automatically save memories into the cloud to then for when you're using your agent later on, pull that in, and bringing your own data, like you said, with AlloyDB. And those 3 things really help improve context and memory, which we see behavior is better for agents.
Absolutely. One last thing that I forgot to mention, and I'm also very excited about, is the data engineering agent. I showed the prompt that I used that was pretty simplified, but I will be following up with a few more examples of a longer prompt that works very well. And one of the great things that the data engineering agent did for us is create all of the pipelines from a data engineering perspective, and at the same time, the orchestration. And one great thing is you can tell it to create a Dataform data engineering pipeline or a DBT pipeline, which is actually new, and I think the data engineering community will be very excited about. So yeah, that's another thing that we can try out. So yes. Anything else, Jack?
I don't know. Do you want to just quickly touch on what's been your favorite part of Next so far?
My favorite part of Next so far has been mingling with everybody. I think that I get a lot of feedback and a lot of questions that are very inspiring for me to create more content and to reach out to people, understand what they're dealing with in production and building their stuff. How about you?
Yeah, I think for me, it's kind of just walking around the showcase floor and seeing what all these different companies are doing right now. Like, I think it's such a cool time we're in for agents, for technology, and kind of just walking around the show floor from booth to booth and seeing how all of these different companies are leveraging agents or just getting pretty inspired, like you said, from chatting with people and seeing what others are building out there.
That's right. And of course, one of my favorite parts was sharing the keynote with you.
Of course,
and doing our
mine
little
too.
fist bumps there. So if you haven't watched it, go watch the replay. And if you have watched it, go check out our repositories and our code labs.
Awesome. Thanks, Lucia.
Thank you.
Hi everyone, I'm Cynthia. I'm from Firebase. I work on the SQL Connect team. SQL Connect is our new SQL product from Firebase. We've launched Data Connect at Cloud Next last year, and we're evolving into SQL Connect to have a more SQL-related focus as a database. So Firebase had Firestore as a NoSQL database for the longest time, and now we're finally having a SQL database built with Postgres on Google Cloud SQL. Right, so I want to demo an app built with the newest features, including real-time, native SQL support, custom resolvers, and caching. So let's get started. Nice, so this is our app's schema, which is built using GraphQL. As you can see, because it's a relational database, everything is defined in tables. So here's how you would do it. GraphQL is the data definition language that we've chosen to use. You can have as many tables as you want. You can join the tables together using foreign keys. And we have default values. And some of them you can define on your own. We can call random UIDs. We can have request server values, including integration with Firebase Auth. Right here. Nice. So after you defined your schema, you want to define your operations. And this is where sort of the Firebase magic comes in. So usually when you have a database, you get your client to talk to your server, and you get your server to talk to your database, right? So Firebase, we abstract all of that for you. So essentially, you define your queries. For example, let's say get dashboard data. Actually, I think it would be better to show you right here. So this is our demo app. It's essentially a stock emoji exchange app. So if you sign in, you can buy emojis, and you can sell emojis as well. And when you buy emoji, the price will go up, and when you sell an emoji, the price will go down. So let's see. So right here is our dashboard, and this is our emoji table from our schema. And this entire page is populated by one query. So right here is our get dashboard data, which takes fields from the emoji table as well as the events table. So the emoji table populates this right here, and the events populate this right here. Nice. So say we were to, and all you have to do is define this query in our GraphQL syntax, which is based off of GraphQL, but we offer a superset of it with new directives, including refresh, which enables real-time refreshes, authentication, cell expression checks, as well as server value integration. So let's try it out here. So we're gonna sign in. This is me. Nice. So after we signed in, we can see we have some currency. Signing in triggers a mutation, and you can see that the auth is user level. So we want to say that only a logged in user can execute this mutation. And then we have the auth.uid, which we get directly from Firestore authentication, or Firebase authentication. So you don't have to pass it in to prevent hacking or DDoSing. So right now we are going to, let's say we're going to buy a ghost emoji. So let's buy 10 of that, or let's buy 9 of that, actually. Nice. So we see that, so first of all, the mutation executed, and this entire thing is written in native SQL. So you can see all the SQL expressions. We update the user price, we update the stock ownership, we update the user accounts. And you can see that the price was reflected in real time. So the price went up. We can see that we own these, own the stocks. And all of this counts as one operation. All you have to do is write this, and essentially every single operation becomes abstracted in our API layer. You can call, what we do is after you define these operations, we generate the SDKs for you. So you can directly call them from your client code. You don't have to do any middleware. You don't have to manage it on your server. It all happens through our Data Connect service. The refresh function that we're launching at Next right now is based on mutation executed. So what we can say is that every time someone buys a stock or sells a stock, we want the dashboard to be updated. You can also define conditions. So basically, if I want to say, only when this person executes a mutation, I want the query to be updated, or only when the stock share is over 10 or 20. Or if you prefer, you can have it based on a time interval as well. Nice. So let's go on to the next one. For example, a lot of people want multiple data sources to be pulled into their client SDKs. So what we do with that is we enabled custom resolvers, which allows you to either write or read from external sources via cloud functions. So let's try it out. So say that what did we just buy? We bought Ghost, right? I can't find it right now. Oh, there it is. So I'm going to copy this, and I'll paste it into X. Nice. So I'm going to copy the URL, paste it in here. So what this does is I've defined a custom resolver which, oh, look, see, the price went up. So my custom resolver reads the X API, and it checks for the correct hashtag, it checks for an emoji. And if that emoji exists, it bumps up the price. So see here, we got event saying that the price went up. And this is all happening in real time as well. What we can also do is, say I'm going to buy 11 more of these, or let's try a different emoji. Say I'll buy 11 more of these. Every time I execute a mutation that buys or sells over 10 shares, I trigger a API which calls Gemini, and Gemini would generate a headline for me. So let's see here. Yes, it says that I've bought. Yes, it made a pun, but it generated a headline which is written into the events table in my database. So what this allows you to do is both read from external sources or write from write into external sources. Another feature that we're launching is native SQL. So as you can see, both buy and sell uses SQL, but what it actually does under the hood is it lets you take advantage of all the extensions that Postgres has to offer. So that includes PG vector for vector search. Ooh, actually, let's try it here. So say I have Apple. Apple via full-text search via Postgres database will give me Apple, obviously. But if I were to do vector search, it gives me the phone, the computer, and I'm actually not sure how airplanes related to Apple, but I'm guessing it's close enough, I guess. Or I think something sparkly, let's say. And yeah, everything shines in here. Another extension it can offer you is the Postgres extension, which is a geo extension. Yes. So in my vicinity, people have bought penguins, people have bought emojis. And this is based on a field in my user schema. And it's doing a geo search using the Postgres extension. Another thing we're offering out of the box are transactions. So say you want something to be atomic. If one thing fails, everything else should fail, like a bank exchange or emoji transaction, I guess. So I'm going to try to trigger a random market activity. It doesn't let me. This is because I've added a access check. So right here, so see how I'm making a query to the user database. It's saying that my current role is user, so I don't get to make this transaction. But if I switch myself to admin, I can trigger a random market activity. See here how the transaction directive allows you to find several mutations or queries. You can pass variables in between, and if one fails, everything else will fail. We also enable views. So views is a type of, it is a very common use case in SQL. Actually, let's try this. Where was I? Where was Ghost? Yeah, so apparently I'm not the largest holder of Ghost. Malcolm Deck is. But this is done through a SQL view, which you can define and you can call as a strongly typed GraphQL SDK. So the difference in here is we have native GraphQL for simple enough queries, and these would be strongly typed. Views are also strongly typed, but you can use native SQL. You can write them with native SQL. And purely native SQL queries and mutations give you free reign, but it also returns in any object. So you would have to define those in your client. Yeah. So the advantage of SQL Connect is that we provide you strongly typed SDKs after you defined your mutations, queries, and schema that allows you to just directly call them in your app. We currently support iOS, Android, as well as web and Flutter. We also have an admin SDK that allows you to, that gives you the access to call them in your server if you so wish. So we're always working on new features. And if you have any requests or use cases you would like to let us know, please reach out to us on Firebase User Voice with the SQL Connect tag. Thank you so much.
Hey folks, I'm here today at Google Cloud Next in the GDE Lounge, and I'm here today with Jigyasa, who's been creating some really amazing things with Google Tools. Can you tell us a little bit about yourself and maybe one project that you're really proud of?
Absolutely. I'm very honored to be here today. My name is Jigyasa and I'm an AI ML engineer. I have built a lot of large-scale, low-latency user personalization and monetization systems, particularly on social media apps, e-commerce platforms, and now ride-sharing. Along with that, I am a Google Developer Expert for cloud and AI, and I'm also been doing a lot of teaching via LinkedIn Learning, instructing folks on how to integrate AI into product architecture and build and evaluate agents, which I think building sometimes can be the easier part, evaluating is the harder part.
Evaluation is actually a really tricky problem. So can you pick just one of the things that you've created that you want to talk to us a little bit about today? Is there any one that stands out as particularly cool?
In terms of cool, I think a project I did with a bunch of GDEs on the AI racing coach for using Gemini was pretty cool. It tops the list for sure.
So can you tell us a little bit about that? What does it do? How does it work? What tech does it use?
Yeah, absolutely. So imagine you are in a racing car and even a millisecond, you forget to press the brake or you just didn't realize there was a turn, specifically for amateur drivers or just learning. Racers, I should rather say. And then you have this real-time coach, which is powered by Gemini, who would tell you throttle or accelerate or push brakes. And it can, we have also defined very coach personas. So, some people maybe are more motivated, in some other tones. And for this, we have built two types. So one is the hot path, on the spot, low latency. And for this, we used Gemini Nano. Because in the paddock, you might not have Wi-Fi access, or the latency can be too much.
You're outside.
Absolutely, and the connection is very flaky. But imagine you've completed a lap and you come closer to the paddock. That is where the data gets stored and uploaded and evaluated by, let's say, the Gemini 3 Pro model. And it converts it into what kind of further coaching you would need in the next lap. Maybe you need, they would want to tell 3 seconds before, or rather just 3 milliseconds before, what is your speed like, and it would evaluate your performance as a whole.
So is this like my headphones here, like sitting in my ear?
Absolutely, yeah.
Oh, so as I'm driving, it's giving me vocal feedback about how to drive better and like find the racing line. And,
Yes.
oh, that's super cool. So how did you build that? Like, did you vibe code that something that cool, or did
You bet.
Really?
Honestly, none of us come from any sort of racing backgrounds. The most I had done prior to that was go-karting, of course,
Okay.
and then driving a Lambo and Aston Martin at Speed Vegas at Last Cloud Next. And
Okay.
who would know that, you know, in a year, the next time I would be at Google Cloud Next, I would be talking about a project. And honestly, this was done in, I would say, a span of like 4 to 6 weeks, with everyone having their own full-time jobs. And this was something people did over the evenings or weekends.
Wow, I am actually floored. So you said you vibe coded it.
Yes.
What AI dev tools did you use? Did you use Gemini CLI? Did you use Anti-Gravity? Did you use AI Studio? Probably didn't use Stitch. Which
Yeah.
ones did you use?
So the first thing that we got from our head racer was telemetry logs. And
Okay.
as I said, none of us knew what those telemetry logs meant.
Of course.
So the first thing that comes to our mind was like upload them to AI Studio and like make sense of it.
Okay.
That's what we did. So we asked it to make sense of it, tell us, what it means, what is lat, long, what is the acceleration happening, throttle, GPS coordinates. It really, acted as an anchor,
Okay.
teaching us the very basics of it.
Okay.
And then we used the prototype mode, the build mode of AI Studio, where we just like prototyped about like, okay, these are the GPS coordinates, how is, visualize the car moving, and where are the points where we would actually need coaching. And the best thing, I could share it with my friends with like one-click deploy. All you need to do is like give their email IDs, and they could, they could see what I was thinking, and not just send screenshots or like send them a GitHub repo and they're like, okay, these are the instructions. That kind of like reduces a lot of friction.
Yeah,
in
so
my
it makes
opinion.
collaboration possible, so you can share ideas, get feedback much easier than having to. Did you even have to like share code?
So there comes the second part. So
Okay.
now that we were all on the same page, we had understood what the problem was about, and we had like an idea of like, okay, this is what we want our UI UX to look like. This is more how we want the voice feedback to look like. That is when anti-gravity came into picture.
Okay.
So we connected. I still remember we were in an auto shop. And on the back of a car, we had a laptop propped up. I wish I could share pictures here.
I
but
think
that would be great.
actually have some, so we'll see if we can figure out how to integrate them into the video.
Absolutely. So it is after work. A couple of us are gathered around that. We connect the GPS sensor. Of course, none of us know how it works. And we tell anti-gravity, and it automatically downloads and installs the driver, writes Python code to extract the GPS data that we have, telemetry
Oh.
logs. So neat. And we were like literally awestruck. Everyone was just like looking at the screens like, wow, that's cool.
So anti-gravity just knew how to interact with this like device. So
Absolutely.
So it was working with an embedded system. That's really cool. I
Yeah.
haven't talked to a lot of people who've done that yet.
Yeah, I think it went on the web, found the manual, which we would have to like search through, installed what was required, wrote Python code. It was pretty neat, in my opinion.
Awesome. So you vibe coded that part. What else did you build? Because like you still needed the part that generated the voice. You needed the part that you needed some sort of app that worked with the driver. Was that running on a phone? Like, tell me a little bit more about the tech stack and how this all ended up coming
It
together.
was all anti-gravity. If I say the tech stack,
Okay.
in all honesty, I think but it actually ran on, it was a web app to begin with,
Okay.
because this was our initial prototype, and we were using Gemini Nano, as I said, for
Okay.
the hot path, immediate no network access built in Chrome. And for initials, we literally had the laptop in a backpack in the car, strapped to the seat, because we didn't have enough hardware. We didn't figure, but definitely part 2, we're doing much more advanced things.
Oh, there's going to be a part 2.
Yes, we're doing it right after I/O.
Oh, cool. So are we gonna iterate on the thing, try to make the driver coach better, make it more effective?
Absolutely, and then we're also gonna move to phone, like Pixel this time, because it does come with smarter hardware,
Okay, that sounds cool. Are you gonna be able to do anything with small
like fine-tuned Gemma, maybe
Yeah.
offline models.
offline? I was gonna ask, are you gonna do offline models or local models on the device? That's
Yes.
really neat. So one of the things I hear from folks a lot is that there's a lot of tool choices out there. There's a lot of libraries out there. There's a lot of models out there. Even from Google, there's a lot of models in the Gemini family. What tips do you have for folks who are getting started and want to build something cool on themselves? Maybe they want to build a go-karting coach, or they want to build something cool with an RC car. What tips would you have for them to get started? How should folks go about learning this stuff?
Yeah, absolutely. I say the first thing is the best form of learning is by doing it. You cannot just like hear videos all the time and, you know, find that perfect moment to get started with. You just have to, you know, jump right in with the sharks. And it's very easy to get overwhelmed, you know, specifically if you have so many tools and you don't come from that background that you have the knowledge to figure out which tool. So I would say start with AI Studio, you know, just ai.dev, browser-based. And then there are like chat mode and build mode. So build mode is what I feel is I find comfortable to get started with. There's a gallery of apps. You find something that's similar. And as I said, one click, deploy and publish. Share it with friends, get feedback. So that is pretty amazing. If you feel you come more from an IDE kind of a background and you know the ins and outs of technology a little bit better, anti-gravity or Gemini CLI. Personally, I'm a huge person of visuals. And even though I like Gemini CLI, I think anti-gravity is like what has stuck the most.
Okay. Yeah, I'm a big anti-gravity fan as well, but I do run both the CLI and anti-gravity all the time. So last thing, why did you become a GDE?
I think for me, like I have been doing open source and I initially started my whole journey with open source and specifically building random Android apps and publishing to the web.
Okay.
I think that's how all we did. And I think like during my whole journey, I realized that a lot of people helped me. Like my first meetup was a Google developers group meetup that I went to. And I think I found people, like-minded people, apart from work, like, you know, we share a lot of like experiences in life and we help each other grow because there is no sense of competition, you know, like we're not in the same workspace, yet we are all working together. So it's a very different environment. And I think slowly and steadily I graduated to GDE, became AI GDE, then Cloud GDE. So it's a way for me to be connected with the community and it also helps me with my day job and become better and of course get early access to all these cool tools and technologies.
No, the early access piece is great and it's fantastic. I love being with the community. It's always the best part of events like this. So I just wanted to thank you for coming and telling us about your projects today. I really appreciate the time.
Yeah, thanks a lot and hope you all had a great conference.
Hey, it's Aja, and I'm here at Next talking to folks in the GDE Lounge about cool things they've built with AI and cool things they've built with AI dev tools. Today I've got Rody with me. Rody, why don't you tell us a little bit about yourself, and then we can talk about some of the cool stuff you've built.
Cool. Yeah, so my name's Rody. I am a DevRel on the anti-gravity DevRel team, and working with dev tools, getting people excited about building with AI, whether it's non-coding tasks or even like building full applications, and especially with existing code bases.
Ooh, existing code bases.
Yeah.
We're going to come back to that. So is there anything that you've built recently that you're like really proud of or you think people would find super cool or interesting?
Yeah, one of the things, so I've been a huge like skills advocate. I think they're like the coolest way to package a bunch of information in condensed space. So I've been looking at putting skills on the client side. So with Firebase, you can use like AI logic, and by having Firestore ship your skills, you can basically create really awesome chatbots with very small context windows. So by loading in a skill, for example, let's
tell me more. I'm not following.
Yeah, so the classic support, you know, like I want to refund this order. Well, a skill is a great way to say, here's how to call the right things, here's how you should respond and what you should look for. But then you also have a skill for upselling, right? And it's going to have a completely different context. You don't want to have the AI be like trying to upsell something when someone's having a bad experience.
So you can
dynamically flavor, yeah.
Yeah, dynamically pick the skills and also kind of sandbox them so that they're not polluting each other's context windows.
Exactly, yep.
So how'd you build that? What'd you use to build that? Did you like write them by hand?
So I used anti-gravity to basically come up with a way to generate a bunch of scripts, and then created the Firestore functions that will basically anytime something's uploaded to file storage, it'll automatically generate the YAML and the metadata. So I didn't have to like write any of the Firestore logic itself. And then in the app, you know, I just all in anti-gravity, built it with Flutter and Firebase.
Cool. So what do you like about anti-gravity?
So one of the cool things about anti-gravity is I feel like it helps me from any part of the journey, whether I'm just trying to update App Store screenshots and generate icons or non-coding tasks, all the way to like working with really deep code bases where I can have either a big mono repo or a bunch of different projects that can open up each one of them in their own agent and have like an agent manager connect them all.
So you brought up a monorepo. What's been your experience working with anti-gravity on, brownfield projects? I like to say that greenfield doesn't really exist because like you write the code and then it's brownfield immediately.
Yeah,
but what's your experience been using anti-gravity on projects that already exist to like add new features or to fix bugs?
So one of the important things to do when you're coming to working with anti-gravity in the existing code base is try to think about AI health. Like how do I make this code base ready to be agentive? And so one of the first things you can do is just try to generate a markdown file for every directory in your project. And it should like basically have a summary of what it does and then all the files below it. And then from there, you're also working on like, what are common skills and things that I'm commonly doing in this code base? And then over time, you're just going to make it easier for you to make these changes. Also, make sure you have tests and do other things because the agent will be able to make a lot of stuff pretty rapidly.
So what you're saying is tests, which I would have pushed for anyway.
Yeah.
Some sort of directory level README that's designed for agents so that
Yes.
it can quickly get context and not have to read all the files.
I call it the context MD is what
Context
I like to go
MD,
with.
great.
Yeah.
And then on top of that, also just making sure that you've actually used reasonable engineering practices so that the agent has a good place to start from.
Totally, yeah. And also, I feel like I've been noticing my architectures change over time. Like I'm going to a way more horizontal flat architecture where like the agents can put state in one layer and it can like, easily refactor. Because you want to be able to tell the agent, like, break this large file into smaller functions and also try to find similar things that are, in the same directory. And then that way, like when you come back to it, you'll also have the better context as well.
That's super cool. So when you're building with anti-gravity, like, have you learned any tips or tricks to make it work really well? I know that I watch you and I'm like, I didn't know you could do that. So do you have any like tips or tricks to work effectively with a tool like anti-gravity?
So for me, I like to exploit the fact that humans are really good at pattern matching. So for me, like looking at like a file system or any type of streaming, you're wanting to find patterns and to see if the agent is following the pattern or falling out of the pattern. Because it's so easy to course correct it and be like, oh, well, you're obviously in the wrong directory, so you must have not read this context. And so skills and MCP servers and a bunch of other things can really help make that better. But really, it's about knowing where you want to head and be really prescriptive. Like, so I like to use like the Gemini app or Notebook LM to create prompts and context so that when I'm coming into anti-gravity, I have like a really clear plan so it can just build what we need.
That's definitely a thing that I've heard kind of this whole week is how important the planning phase is becoming.
Yes.
And how important it is to have a very clear idea, not necessarily how you want to build, but where you want to go and what success looks like going in so that you can steer the agents in the right direction.
Yeah, in fact, like I've seen a lot of people like even in the hackathons that have transitioned over time. Like it used to be you're spending all the time just trying to get it working, get your database connected and all that. But now like 60% of the time should be spent in the design phase of like, what do we actually want to do? Because then it's just technology choices and how fast can we get to the MVP?
Yeah, no, I agree with that. And one of my most successful vibe coding projects started with several hours in Notebook LM and in the Gemini app doing research, figuring out what was possible, what was in the scope of the problem I was trying to solve. It was great. So, folks, I've heard there's a lot of stuff out there. Every model provider's got multiple models. There's multiple AI dev tools.
Yeah.
There's a lot of different ways you can do it. Do you use a live API? Do you not use a live API? Do you use an LLM or do you actually use an old school machine learning model?
Yeah.
How do folks get started? Like lots of people have really cool ideas they want to build, but they don't know where to start. And like they know that it should be possible, but how would you get started? How would you tell someone to get started if they came to you?
Yeah, totally. I like to think about like the universe of AI. Like there's going to be a lot of different parts of like the things that you're going to be exposed to. And honestly, like try to find like the idea and everything that you want to do. And then sometimes it's going to be, I'm going to like just want to build this prototype and I just want to share it with people. I'm going to go to AI Studio. I'm going to build that and I'm going to be able to easily just share with a link. But then other times I'm like, I have this context and this problem I really want to break down. I'm going to go to Notebook LM or some other type of app. And then other times I'm like, I have this idea. I just want to take it further or I want to connect to real sources and stuff. So like I know people that are like reading their email or like creating a bunch of different types of files. And you can do that inside of these editors with all these MCPs that are like so powerful now. So like think about the workflows that you want to accomplish, like any skills or tasks that can make that possible. And then also you just may find that like sometimes you're just in the dreaming phase, like, and that's where I really like Stitch. And so I can just go like, oh, like how would this look like before I get started?
I like using Stitch to figure out if my idea makes it out of my brain to something that another person might understand.
Because if you can't describe it, and make it visually, you're like, oh, maybe I don't know the idea well.
Yeah, maybe I haven't thought this through yet.
Yeah.
I just want to thank you for your time and thank you for the ideas that you've shared with me and the audience. I really hope that this helps them get started with anti-gravity.
Absolutely. Thanks.
Hi, it's Aja again, and we're here at Next in the GDE Lounge. We're going to be talking today with Richard Seroter about AI dev tools. And, I kind of want to know, do you actually use our AI dev tools?
It's a good question. I do. I don't code it every day, but I try to be a builder because I don't like talking about our stuff if I don't know how to use it.
Fair enough. So what thoughts do you have? Like, are you a CLI person? Are you more an anti-gravity person? You an AI Studio or Stitch? Like, is there a tool that you find yourself gravitating toward?
I mean, I lose any dev credibility by saying I like a UI. I mean, I'll do the terminal stuff. Like, I'll use the CLI, it's fine. Actually, I usually keep it open all day just to ask one-off questions. I find that it's good for that, not when I'm trying to do a long-running thing. Sometimes I like going into a IDE type tool instead. Like, let's kick off a thing, let's work on a whole exercise, plug in some MCPs, whatever, like have a goal. CLI is kind of doing one-off, just answer a quick question for me.
Okay, tell me more about that, because that's not a use case I had thought of. Do you have an example of a question you might ask in the CLI?
Yeah, I mean, part of the nice piece now that I plug in our developer knowledge API or things like that, so if I have a quick product question, I know it's actually coming back accurately too. It's not doing the web search. It's actually pulling the latest. So if I go, hey, how do I deploy to a worker pool? And I know it knows about Cloud Run worker pools now, and it's going to pull the latest info. And that's just a one-off question. It's a question answer, almost a fancier chatbot at times, but a really well-connected one.
Yeah, so it doesn't have the problem of the knowledge cutoff date then, because it's always got the latest stuff. So everything we announced here at Next is already there.
I think that is such an underrated value thing, because my reason I sometimes got so annoyed with agentic coding tools was that, hey, I'm asking about a new feature in Go or Java, and it's like, I don't know what you're talking about.
Yeah.
And it's right there. And I send it with a link, maybe it doesn't pick it up. But now to be able to just know, and especially because that developer knowledge API isn't just Cloud Docs, it's pulling now Go Docs, it's pulling this from Firebase. It's why does a developer need to know there's 9 doc sets? You shouldn't.
No, you
just ask for stuff and get back trusted info. So I love that scenario where I can have a trusted little smart thing hanging out there answering questions.
So are there any other surprising use cases you found for these tools? I've heard some really strange ones internally, but I'm curious if you have any interesting use cases that people may not expect.
For the dev tools?
For the dev tools.
I mean, my favorite thing I like doing for both demonstrations and Richard building is connecting my agentic IDE anti-gravity to Stitch.
Okay.
I love it so much because I'm terrible at front end. I like a good front end. They're beautiful things. I would spend all week centering a div. I'm just not good at it. So I'll often in a demonstration actually ask the IDE, hey, understand something, use the browser, understand the style, whatever, go send the Stitch for a design, pull it back in and literally build the app. I'm doing something in that use case that would have literally taken Richard days, if not a week before. I'm literally only constrained by my thoughts now. That's wild, because I would have given up on these projects, and I did often.
Yeah.
Because it was this looks terrible, or I can't show this to a customer, or do whatever. I'm embarrassing myself. I'm not anymore. So now I finish more projects I think I ever have in 15 years.
Huh. That's awesome. So what you're using is you're finding ways to use the different tools basically as agents in and of themselves, and they collaborate together to work on a goal, where Stitch is working on the front end and anti-gravity is working on the back end?
Yeah, and even in this case, the browser's doing the research. So if I'm saying, hey, go do research and understand the colors and fonts of my brand so that you can feed that into Stitch right, so that it looks correct, those are all different tasks for us, right? I'd open up my browser, I would do 10 blue links, I would do whatever. I'm just now indicating all of that with maybe even a single prompt, if not a short conversation. That's amazing.
And you can stay in context. You don't open a browser and open another window and open
100%.
another one. It's all right there.
It's all right there. And so now I'm not sitting here thinking about, wait, what did you finish? And yes, agents might be finishing at different times, but as you say, I'm just sitting in one command center sort of view of this sort of thing. That feels like the future. And for many, it's the present. But I think for most of us, we're still getting used to how do we delegate? What's the right way to even instruct all these things? But as you look at that, again, we just get this outcome focus.
Yeah, and I'm really liking that I'm hearing that a lot this week. Focus on the outcome. Focus on what you want,
right?
Not necessarily how to get there.
Now, for many of us, that might be unnatural because we're also used to building it incrementally.
Yeah.
And then, yeah, you start with some sort of spec or goal, but it's almost emergent. The emergent window has shrunk to nothing.
Yeah.
And so all of a sudden, like, I just went from like, I wonder if I could, to, I'm looking at it really quickly.
Yeah.
That's going to probably cause some other downstream impact that I can't think of yet, but maybe it's just learning loops are that much faster. And I can look at that immediately and go, that's terrible. I shouldn't have built that, but I lost 20 minutes, not 4 days.
There's many things that I have vibe coded where I'm like, I wonder if that would work. And I try it and it did not. And so we abandon that branch and we go back and we do something else. And it's great that I can get through that in 5 minutes, not 2 weeks.
And the one I've been doing lately, especially as our team, or at least I have been taking on some more product areas and things. I did my first Flutter project or my first Angular or things like that, because it was like, I was always intimidated by those frameworks because I'm not a front end guy. I got, it's a lot of scaffolding. I don't want to set all this up. But instead, when I can go into one of these tools, whether that's CLIs or IDEs, and say, hey, I'd like to build this type of app, not even just the basic Hello World tutorial, but use the MCP to pull those in to maybe guide you. But hey, I'm trying to build a functional app that does this, that uses this framework. I've tried 3 or 4 frameworks that I've always been intimidated by over the last month. And then in 15, 20 minutes, I have something, and then I can ask the agent, hey, how's this work? Oh, what does this do? So I'm learning through a personalized result.
Yeah.
My gosh, it's so much better than just click here, type these words. And like, all I learned was how to follow a tutorial.
Yep.
In this case, I have an outcome, and now I'm dissecting the outcome to figure out how does this piece together. Am I learning it as deeply as if I went to a class and did a boot camp? No. But am I seeing what I wanted to see from it? Yeah.
Yeah, I'm doing the exact same thing with Go right now. I'm building Go agents.
Is that right?
Not a gopher. Really like the Go community, and so I'm like, okay, well, let's use ADK Go as not released. I started learning Go, and I'm building stuff with it, and I'm like, hey, how does that work? It's exactly the same.
So do you feel less language constrained? Like, I don't write Python, and yet I've written a decent amount of Python the last few months because there were certain things that only had a package there, or that was something that works well with Agent Engine or things. Mm-hmm. And so I'm not intimidated by that. Before it'd be like, I guess I'm just not trying that service. Now it doesn't matter. I'll build a Python agent. It works fine.
Yeah, exactly how I feel. There's been a lot of projects where I've wanted the power of Go, but learning a new language was super intimidating and I didn't have enough time.
Yeah.
And now I can just get the power of Go. It's great. So the last question I've been asking everyone is, how do you get started? There are so many models, so many tools. Google's got several tools, but there's plenty of tools from other companies as well. Every model has like different versions in the family, and then you've got you've got gemmas, models from other providers. Folks want to build cool stuff. They have amazing ideas, but they try to navigate the space and like, I don't even know what is an AI studio, what is an anti-gravity. So if you were talking to someone who had a really cool idea they wanted to build, where would you tell them to get started?
Yeah, I guess the second question would be, what are you thinking about? It's a web application?
Let's go with web.
AI Studio is great.
Okay.
Google AI Studio, to just say I'm going from intent to now even adding a box and saying give me Firebase auth if I wanted, or a database. Amazing. Like, I just go from idea to implementation like that. Beautiful stuff. I think when I'm thinking of building a system or an application, I'd be looking more to my IDE. Plenty of people will jump to terminal, and that's fine. Mm-hmm. For me, I still at least like the read-only code editor view for me, basically, at this point, to run through there. I guess my advice would be, don't over-optimize at the beginning. Don't be like, okay, when I'm starting to build, I need to first try every model and every tool. Then you just have a really cool setup and you've produced nothing. And I don't know if you have, and I think we see this on social sometimes. People advertising their unbelievable setups, and someone will be like, what have you built? Like, nothing yet. I don't know. Like, maybe grow your setup after you keep getting wins. And so otherwise you're going to be really intimidated. I have to use 7 harnesses and all these clouds and all these models, and none of that's the point, because arguably anybody who uses your output couldn't care less how you produced it. Mm-hmm. The point was the output and the outcome. And so just build the thing. And when you get comfortable with that thing, and you're like, I wonder if this other thing works too. Awesome. I don't know, win after win.
So baby steps.
Yeah.
Have an idea, start an AI studio if it's web-based, and iterate.
Get the dopamine hit, right? That's what motivates us, right? Yeah. Like, I did something, that's awesome. I want to do it again. That's cool, that's great. So yeah, don't over-index on the tools. Still stay obsessed with, like, I can do anything I think of now, and be obsessed with that.
So focus on the outcomes. Well, thank you so much for giving us some time today. I really enjoyed talking to you.
Absolutely. Thanks, everybody.
Well, folks, that is officially a wrap on our Google Cloud Next coverage. Thank you so much for coming along for the ride with us over these last couple of weeks, by the way. If today's episode has you itching to get more hands-on, you are in luck. We have an incredible 77 code labs tied back to Next right now, and 55 of those are brand new. You can find the blog post with all of those code labs linked in the description below. And remember, if you missed out on any of the live action, you can also find the links to last week's episodes straight from the show floor down there too. We'll see you right back here next week for a brand new episode of Google Cloud Live. But before we head out, I wanted to share that we also just launched 2 new learning paths on Gear, Gemini Enterprise Agent Ready. Gear is your new home base to build and scale AI agents, and the new paths cover deploying production-ready agents and scaling agents across the enterprise. So from hello world to production, you'll get curated learning paths, earn official badges, and connect with a massive community of builders. Finally, if you are looking to also get your hands dirty with the latest AI reference architectures, you need to check out the AI Learning Lab. These are live build-along sessions hosted by GDEs, professional developers who are actually building this stuff in the wild, and they'll walk you through everything from anti-gravity data pipelines to agentic reasoning. It's totally free, and we're providing the Google Cloud credits to fuel your build. So register at the link ailearninglab.live. We're going to include all those links here. And have a great week, everybody. We will see you next week.